Hello, my name is Zubair Hassan, and this is a peer-created assignment course project for machine learning foundations for product managers from Duke University. The task is to predict the electrical energy output of a combined cycle power plant, a machine learning approach. The business problem is to predict the power plant energy output given the weather data. The data set available to us is primarily the temperature, ambient pressure, relative humidity, exhaust vacuum, and of course the net hourly electrical energy output, signified as PE. There are about 9,500 observations available in this data set. The modeling approach I took was for feature selection. We have temperature, pressure, humidity, and vacuum because these factors are directly impacting the PowerPoint efficiency. As for modeling alternatives, I use linear regression and random forest. Linear regression because it's simple and interpretable and suitable for initial explorations, which it proved. And random forest, it handles non-relationships, if any, and if there are any outliers that are handled more effectively, that we will also see in my comparison later on. So for the evaluation metric, I use RMSE primarily and also MAE as a backup just to ensure if there are any variations and RMSE is not able to capture that, then MAE is there. The primary factor to select the model was the lowest RMSE because it indicates a better model performance in our case. Okay, for building the model, I first started off from Excel, built a linear regression model in there using a 80-20 test train split using a random and percentile methods, but I was not aware of any other data analysis tools that could help me predict my outputs based on the algorithms that we have. So I switched over to Python, took some tutorials and courses, and then was able to build simple regression and the random forest models in Python for comparison and scalability purposes. I also used an 80-20 person train and test split using the built-in functions, and I cross-validated these results between Excel and Python, and then within Python between the regression and the random forest outputs. So in Excel, I use a rand and the percentile method to split the data and ensure that I have achieved the 80-20% split. So in Excel, I calculated the linear regression statistics. Notice strong correlation in the variables and great model fit, where 93% of the output variance is explainable by the input variables, and also an adjusted R-square, which indicates that input variables contribute to the model fit. So I'm confident to move on with this. I calculated the coefficients and then used them to apply in a reverse order to one of the test observations to get the results for the comparison purposes, which is very close to that, but I understand this is just one of those data points and this may not be applicable, but this shows a good fit of the model. For now, then I use the PE variables predictions on the test data set by drawing a regression line. I identified some of the outliers, but since the number is small, so I did not change that in order to be able to compare it with Python results. So the RMSE I got from Excel is 4.17 and MAE is 3.67. Let's compare that to the Python results. In Python, I created this model to calculate the linear regression, used 20% test size, and then applied the regression on the training data and drew the results on the test results on the test data as well. And we could see the RMSE for the test data is 4.64 and MAE is 3.77. I plotted the actual values of PE in the test data to be the predicted values of PE, and it seems like a good fit. There are very few outliers. That is one shown by the mean absolute error. at the same coordinates as we saw in Excel. So the second model I built in Python was the random forest. I use a 20% test size again, just like in the regression, a linear regression model. And by using the n estimator of 100%, which is also the 100, that is also the default variable that passed into this function of random forest regressor. I treat it as a hyperparameter, and then I tried different values for this by tuning it. So if I use the n estimator at 10, the root mean square I get is 4.01, and if I go to 10,000 of those estimators, then the root mean square I get is 3.803, which is almost the same as 1,000. So this means there is no need to go to 10,000 estimators. And the difference between 1,000 and 100 is very minute, so I went with the default to calculate my final results, because I also need to understand the cost and efficiency of the model. And by applying the random forest, I received an RMSE of 3.81 and MAE of 2.82, which is the lowest of all the models that I've run. The RMSE is the primary evaluation metric, which captures the average error magnitude and penalizes the larger outliers. And for the comparison of the RMSE and MAE values, the best values I received was from Python-based random forest algorithm. Random forest in Python shows the best results with the lowest RMSE and MAE. It suggests that it captured the underlying trend well, that is shown by MAE, but also it does not overestimate or underestimate some of the values. And there is a possibility of that in Excel and Python-based linear regression compared to the random forest. Overall, all the models show good trend capture by showing lower MAE than the RMSE. The Excel linear regression RMSE is lower than Python. This is potentially due to different data splits of randomizing the data, or the implementation differences in both the platform.